So hello guys, welcome to my channel. Today in this video we will discuss about the Leetcode POTD problem, number of islands. And before moving towards the problem, let's talk a little bit about myself. So my name is Shushil De. I am specialist at Code Forces and Knight at Leetcode. I have solved more than 900 problems at Code Forces and solved more than 600 at Leetcode. So now let's move on towards the problem. So what is given here is that given an m cross n 2D binary grid which represents a map of ones that signifies land and zeros that signifies water. That means we have simply given a 2D matrix, okay, where each cell can be 1 or can be 0. If it is 1 then it signifies land, or if it is 0 it signifies water, right? And we have to simply return the number of islands here. So first of all, let's make sense what is basically mean by an island. An island is basically a piece of land surrounded by water, and it is formed by connecting adjacent lands horizontally and vertically. This particular segment is very important, that only we can connect the adjacent lands horizontally and vertically. That means in the 2D matrix we can simply connect the ones vertically and horizontally to make an entire island. And finally we have to return the number of groups we have formed. So forth. Okay, and that will be the number of island here. Okay, so here let's see some example to understand this more clearly. So let's draw a 2D matrix here, right? So so this is a 2D matrix, okay, where 1 signifies land and the 0 signifies water. Okay, so now from this one we are only allowed to move horizontally and vertically, right? So from here we can move one step vertically downward and connecting the both ones, making one island here, right? And this will be the second island. Okay, that means we simply have to group the ones horizontally and vertically. Okay, in this case we cannot move diagonally, we are only allowed to move vertically. For example, in this case we are not allowed, let's say here is a 1 and here is 0, and well, let's take another example here. Let's say there is a 1, there is 0, there is 1, there is 0, 0, 1, 1, 1, 1. So carefully observe this example. In this case, at first we are starting to this position, right? Then we are not allowed to move diagonally to connect these ones to make an island. We are only allowed to move horizontally and vertically. That means we are fixed in this location, and this makes an island. Okay, this is one island, and this group will make this second island. Okay, this group will make the second island. So here are total two islands are here, right? So there are total two islands. Okay, so what we will simply do to solve this problem, we will use BFS traversal. Okay, we will use BFS traversal. And at first let me write the example here. So we will do BFS traversal whenever we encounter an unvisited cell that consists one, right? An unvisited land cell. Whenever we find an unvisited land cell, we will start to do BFS traversal from that particular position. And in this BFS traversal, if I am currently I and j cell, then it's all the children cell will be I comma j minus 1, here I plus 1 comma j, I minus 1 comma j, and here I comma j plus 1, right? In this four location I will check whether any of these cells is 1 or 0. If this is 1, then we will simply mark this as visited and push it inside our queue, as we do in our in a typically PFS traversal. And if this is 0, we just simply ignore, right? So for the for example, here at first we will encounter this one which is both unvisited because we are encountering it for the first time. So we will simply push it inside a queue. Okay, we will simply push basically the location of that index, right? And then we will start to do the BFS traversal. And here, as there are no surrounding one, so the BFS traversal will be completed here. Okay, then we will move forward, and when we encounter this position, this one, we will again starting to do BFS traversal. Okay, we will move from this direction. We will move one step vertically downward. Then we will get this one. Then here are lots of surrounding ones. So this will eventually create an entire group of ones and make all the ones visited. Okay, so to solve this problem, what we will simply do, we will simply we will simply run a VFS traversal. Okay, simply run a VFS traversal. We will take a map of pair of int comma int. Okay, this map will be work as the visiting array. Okay, this will be work as visiting array. Okay, this will be work as visiting array that will store the result about which cell is visited or not. Okay, if a cell is visited, we will simply mark that inside our map as 1. Okay, or otherwise it will equal to 0, right? So, and we in this fashion we will count the total number of connected ones. Okay, and if we simply run a loop here, for example, if I run a loop, let's change the ink. Whenever we visit a cell which is already visited, for example, we are visiting a cell that is already visited, or a cell which is marked with 0, that means it is basically water, then we will simply continue. Okay, we will not move forward. But if we get an unvisited cell, okay, if we get an unvisited cell which is marked at 1, we will simply push it inside our queue. We will push that cell inside our queue and mark that particular cell as visited. Now we will simply run our BFS traversal here, and in each iteration after this continue statement, we will take a counter variable. Okay, we will take a counter variable. Let's name this variable as CNT. So this CNT basically signify signify the number of islands. So let's start to do code. Then it will be more simple to understand. Okay, so let's do step by step. So what we will do at first, we will simply declare a map, right? A map of pair int comma int. Okay, this basically work as the visiting array. Okay, this will be used to mark the cells, particular cells which has been visited. Okay, and we will store the number of rows in n, that will be the size of the grid. Then we will store the number of columns inside m. Okay, this is basically number of columns, and this is basically number of rows. Okay, so now we will run a loop traversing all the cells of the matrix step by step. Okay, now if our current cell is water, that means if it is 0, or if it is already visited, then we don't need to move further. Okay, so in this case we'll simply continue. And if it is not the case, that means our current cell is 1 and it is not visited, then we will simply push it in the inside a queue. Okay, so first declare a pair of queue. Here I am declaring a queue of pairs and simply pushing the current index inside the queue, right? And I also have to mark the current index as visited. Now we will simply do a BFS traversal here, and we can move in four directions, right? Left, right, or up and down, right? We can only move in these directions, right? If I am in this cell I comma j, can only move in this direction, right? So here I can do I minus 1 j, I plus 1 j, I comma j plus 1, or I comma j minus 1. Okay, so we will simply take a move array. At first I will store q dot front, then int x is equals to temp dot first. This is basically a queue of pairs, right? So each of the q dot front will definitely be a pair, and I will store the first element inside x and the second inside y. That means I am basically storing the number of corresponding number of rows in x and corresponding number of columns in y, right? And then here I have to declare a vector of pair that will be moves. Okay, I have to declare a vector of pair name move that basically contain all the possible moves from a given index. For example, the what is the possible movement? I can move one towards left, I can move one towards right. Okay, so in the following fashion there are four possible movements. Okay, minus 1 comma 0, then 0 comma 1, and 0 comma minus 1, right? So these four possible movement is possible here. Okay, so I will simply traverse to the possible movements and declare the index of the surrounding cells, that will be x plus move dot first, and the y temp will be y plus move dot second. Then we will check if this current index is valid or not. That is basically this index must be inside the grid, right? If it is goes outside the grid, this will not be valid. So first of all we have to check these indexes are valid or not. So I have to create a function is valid here, bool is valid. This will check whether our indexes are within the grid or not. If it is inside the grid, then it will return true, and if it is outside the grid, then it will return false. Okay, so we'll simply return here x underscore temp greater than equal to 0, and x underscore temp less than n, and y underscore temp equal to 0, and y underscore temp less than m. Okay, and here I have to pass the variable n and m. Okay, so first I we have to check whether it is valid or not. Then we have to check whether this index comprises of land or water, right? If it is land, then we will simply ignore. If it is sorry, if it is water, then we will simply ignore the that cell, and if it is land, then we will push that in the queue and move forward. And we will have also check whether these indexes are visited or not. So we will check that whether these indexes are visited or not. If it is unvisited, that means empty of x temp comma y temp. If this is equal to 0, then in that case, so there are three conditions. Okay, first we have to check whether x temp y temp is valid or not. Then we have to check whether this value is 1 or not, whether this is comprises of land or water. Then I have to check whether it is visited or not, and then we can push that inside our queue. and then mark the current cell as visited. Okay, so this is a simple BFS traversal, and yeah, we have to pop element here, otherwise here will be an infinite loop and give resulting in giving TL. So this is the simple BFS traversal here. Okay, this is a simple BFS traversal, and I have to take a counter variable here. Here I have to take a counter variable that basically counts how many times this BFS call is happening. Okay, because the number of times the BFS call is happening is basically the number of connected components present here. Because if all the cells are connected, then in the single BFS traversal, all the ones are visited. Okay, but if there are still unvisited ones, that means these ones must be present in some other island. Okay, so in that case, we have to count the number of BFS traversal we are doing here, and that will be our answer. So at last, we just return this CNT, right? So here return the CNT. So let's run this code. They are giving some error. Oh yes, I have forget to write int here. There are still some errors. I think I have do some mistake. What mistakes I have done here? Okay, so I have do a terrible mistake here. This will be a character, right? Because here the matrix is given as a matrix of characters, and I have taken here as integer one. So this is giving error here. Now let's start to compile this. I think now this will work fine. Okay, now this is working well. Now let's submit this. Okay, so it is accepted here. So the problem is very simple. We just have to run BFS traversal and have to check the number of times the BFS traversal is happening, and that is basically the answer. And the time complexity here will be, the time complexity is basically order of n into m, right? Order of n into m, because here we are traversing each cell only once by using two loops here. Okay, and inside the loop, as we are using a visiting array, we will not repeat any cell that is already visited, and so the time complexity will be order of n into m, and the space complexity here is also, here I am basically using a map, right? So what will be the size of the map? This is basically also n into m, the size of n into m. Okay, so the space complexity will also be n into m, right? So that's the case. Okay, if you have cleared the solution uh, clearly, then like this video and subscribe to my channel. Okay, thank you.